Do you know that story about a boy who looked into a mirror and wondered if the reflection had a life of its own? What if it wasn't just a reflection? What if the mirror showed another world? A perfect twin of ours, but with its own unique rules. Sounds weird, right? But in 2018, Neil Turok and his colleagues proposed something just as fascinating, a mirror universe born alongside ours at the Big Bang. But this twin is nothing like ours. This universe is where the time flows backward, antimatter dominates, and physics dances to a different tune. Our universe is full of unsolved puzzles. Like why there was more matter than antimatter at the beginning of the universe, or why time only flows forward, or what is dark matter. Of course, theories have been proposed to provide some solution to it, but those are highly complex. What Neil Turok's theory does is that it rests on simplicity. Instead of invoking multiple dimensions or complex mechanisms, Neil's model suggests that universe and its mirror counterpart are perfectly symmetrical. Think of it as a cosmic palindrome. The beginning and the end look the same. Consider these long-standing puzzles: the matter and the antimatter imbalance. In the beginning moments of the universe, the matter and antimatter were perfectly balanced. Well, almost perfectly balanced. Something favored matter over antimatter, resulting in a tiny surplus of matter. How tiny? For every billion particles of antimatter, there were a billion plus one particle of matter. That tiny excess of one particle per billion is what eventually made up of all matters we see today: the stars, the planets, the galaxies, and us. And you know what happens when matter and antimatter meet? They annihilate each other, releasing energy. After the Big Bang, most of the matter and antimatter in the universe wiped each other out. But because of this tiny imbalance, just one extra particle of matter for every billion, there were some leftover. And that leftover matter became the building block of the universe as we know it. Now, physicists are still trying to figure out why this imbalance existed, why universe favored matter. Now, this mystery is known as Barion Asymmetry. You can Google it, and solving it could unlock answers to the origin of the universe. Now, Turok's theory suggests a solution to it. What it says that all those missing antimatter in this universe, well, it isn't here. It's at the mirror universe. So there, things happen exactly in opposite way. So there, antimatter and matter were almost the same, except that antimatter was billion plus one over a billion particles of matter. So what's there would all be made of antimatter. It's worth noting that things made out of antimatter will not behave weirdly as we may think. Like we may think that it'll have an anti-gravity. It will basically repel everything. It will work on weird physical principles, but that is not the case. Physics would be pretty much the same if it was matter or antimatter. Remember that movie, The Curious Case of Benjamin Button? Brad Pitt's character is born as an old man and grows younger as time passes. This is a clever narrative device prodding us to think about the course of our lives in a different way. And there is a good reason why reversing the relative direction of time is an effective tool of the imagination. In the actual non-imaginary world, it never happens. Time has a direction, an arrow pointing from past to the future, and it has same direction for everybody. What does it mean that the time has a direction? Now think about watching a movie played in reverse. Generally, it is pretty clear that we are seeing something running in wrong way in time. A classic example is a diver and a pool. If the diver dives and then there's a big splash followed by waves bouncing around the water, all is normal. But if you see a pool that starts with waves, which collects into a big splash and the process lifting a diver up onto the board and becoming perfectly calm, we know something's up. The movie is played backwards. Certain events in the real world always happen in same order. It's dive, splash, waves, never wave, splash, spit out a diver. Now take milk, mix it into a cup of black coffee. And never take coffee and milk and separate it into two liquids. Sequences of this sort are called irreversible process. We are free to imagine that this kind of sequence playing out in reverse. But if we actually see it happen, we suspect some trickery rather than faithful reproduction of reality. Irreversible processes are the heart of arrow of time. Events happen in some sequence and not in others. Furthermore, this ordering is perfectly consistent as far as we know throughout the observable universe. Someday we might find a planet in distant solar system that contains intelligent life, but nobody suspects that we will find a planet on which aliens regularly separate milk and coffee with few casual swirls of spoon. Why isn't that surprising? It's a big universe out there. Things might happen very well in all sorts of sequence, but they don't. For certain kind of processes, roughly speaking, complicated action with a lot of individual moving parts, there seems to be an allowed order that is somehow built into very fabric of the world. Out of time, then, is a brute fact about our universe. Arguably the brute fact about our universe. The fact that things happen in one order and not in the reverse order is deeply ingrained in how we live in the world. Why is like that? All the equations given by Newton and Einstein works the same, immaterial of direction of time. So physics does not restrict us from moving back into the time, and yet it is not possible. Again, there is asymmetry here. Now, as per Turok's theory, this asymmetry is settled, but in mirror universe. The entropy over here always increases. It is as per the second law of thermodynamics. Entropy will always increase. Things will always go from order to disorder. But exactly opposite happens in the mirror universe. There, things go from disorder to order. Now, this is as per Turok's theory. The entropy there decreases over time, and time as we know it reverses. Just for fun, let's see what would happen if entropy decreases. Time would run backwards. Processes we associate with time moving forward would reverse. A cup that shatters would spontaneously reassemble, and the spilled water would leap back into the cup. Heat would flow from cold to hot. Ice cubes wouldn't melt. Instead, puddles of water would freeze back into perfectly shaped cube. Now, machines could generate infinite amount of energy without fuel as disorder decreases, making perpetual motion machine possible. And instead of eating to sustain energy, food would move backwards out of you, and you would somehow absorb energy directly into more ordered state. Evolution as we know it would stop. Evolution relies on random mutation and entropy to drive the change. In a decreasing entropy world, life might never have developed at all. Stars form from collapsing gas clouds, a process driven by entropy. A universe where entropy decreases might never allow stars, planets, galaxies to form at the first place. Big Bang would go in reverse. Instead of expanding, the universe might contract into perfectly ordered singularity, undoing all creations. Alright, now let's go to our last puzzle, the dark matter mystery. The dark matter puzzle is one of the biggest mysteries in modern physics and cosmology. The dark matter is a hypothetical form of matter that doesn't emit, absorb, or reflect light, or any other form of electromagnetic radiation, which is why we call it dark. Even though we can't see it, we know it exists because of its gravitational effect on visible matter. It makes up a large part of the universe. About 27% of universe's total mass energy content is believed to be dark matter. It is far more than the ordinary matter, the stuff that makes up stars, planets, and everything we see, which only accounts for about 5%. The main reason dark matter is a puzzle is that we can't detect it directly. We know that it's there. It affects the motion of galaxies, galaxy cluster, and light traveling through the space, but it doesn't interact with light or any other form of electromagnetic radiation in a way ordinary matter does. That means we can't simply point a telescope at it and see it. When scientists study how galaxies rotate, they notice that the stars at the outer edge of the galaxies are moving faster than expected based on the visible matter. Now, this is a sign that there is unseen mass, the dark matter, providing extra gravitational pull to keep the stars from flying apart. The same thing when scientists observe galaxy clusters. Dark matter is believed to be the glue holding these massive structures together. Without it, galaxies would scatter instead of staying bound together. But why is that? Dark matter mystery, something that we cannot see, but it's there. Well, mirror universe theory suggests that instead of figuring out what dark matter is, it could simply be the gravitational effect of the mirror universe on ours. How? This universe is filled with what is called as left-handed neutrinos. A neutrino is a subatomic particle like electrons and protons, but it's incredibly small and almost massless. There is a tiny, almost ghost-like particles that are all around us, passing through our body by trillions every second without you ever noticing. They are super light and barely interacts with anything, kind of like introverts of particle world. They spin in a way physicists call left-handed. But what if neutrinos could spin the other way, right-handed? That's something we haven't seen in our universe yet. They might be out there, but if they exist, they are even more shy and harder to detect than the neutrinos we already know. Neil Turok's mirror universe suggests that these mysterious right-handed neutrinos actually live in the mirror universe. While left-handed neutrinos dominate here, right-handed ones could dominate there. Instead of inventing new particles or forces, right-hand neutrinos might be behind the job. There are certain things in the universe that is not symmetric. Turok's theory does provide some very simplistic solution to these mysteries. But are they true? Let me know what you think about it, and I'll see you next time around. Bye bye.